Right. Hello. I am representing Group November this afternoon. We have constructed a sampling synthesizer, which hopefully a lot of you had a bit of a play on upstairs, or at least heard making noise in the corner. The basic premise is that you have a load of sounds you've recorded beforehand, and you want to get it to play them back at different pitches to possibly hilarious effect. Unfortunately, it doesn't result in anything you can see, which, well, I'll try and explain stuff as best I can. The main problem, of course, is how do you change pitch of the sound? This is one of the main things we had to tackle. First off, here, bit of sound, lovely. Might be sampled digitally a bit like this. You would have more sample points, but I couldn't be bothered to draw them all. So imagine that would work. Perhaps we want to increase the frequency of this sound when we play it out. The method we've used to do this is based on linear interpolation and resampling. It's slightly complicated. To raise the frequency of the sound, you need to resample to a lower sampling frequency. So in order to do that, you take all your original sample points. You want to make a new set, these red ones. So we're taking fewer samples for each bit of the sound. And when we want to take one that's between two other points, we just sort of draw a line, take the dot in between. If you're clever, you've got a cunning algorithm, you can do it all with integers, so it's quick. It's not a problem in hardware or software. So from the blue samples, from our original blue wave, we take some nice red ones, which is the same as if once you've calculated them, it's as if you've sampled your original blue wave at a lower sampling frequency of these red points. What good's that, I hear you say? No? Okay. What happens if you then pretend your red samples are in fact at the same sampling frequency as you were before, and just play them out? So you play them out close together. Lo and behold, your lovely little sound wave now has a high frequency, and you've shifted the pitch. So that's how all the magical sound stuff works. On to the general system overview. Now, and this is proposed design. I prefer to think of it as more where we could go if we had a bit more time. But I think we got most of it done. In hardware, we were working on a DE2 board with a soft-core processor. The whole hardware system is completely independent. You don't need to have a laptop connected or anything. We've got hardware modules that capture MIDI messages off a serial input. So it is compatible with any MIDI source. We had a little rubbish, frankly, keyboard hooked up, but you could hook up MIDI files played through from a computer, drum kits, all sorts of fancy stuff. When you receive a MIDI signal, it sends an interrupt to our main controlling routine. The controlling routine goes, oh, let's play something. The playing routine, well, I'll start again. All our samples are stored on SD cards in handy little file formats. You can just hot swap them while you're playing Reload a Bank. When you load a bank, you fetch like the table of contents from the SD card, store it somewhere in memory so you can get to it quicker. Yes. When you need to fetch a sample, look it up in there, grab it, stick it in your sample cache. Play does stuff with that. I'm sure there's a diagram, you can work it out. We were hoping to have multiple interpolation modules so we could have multiple channel outputs. We got about as far as this, so we had all that done, and a hardware interpolator that worked really nicely, hit a bit of a brick wall in that this didn't like talking to this. I had to go back through there, which was really slow and didn't actually achieve the desired effect. So lacking time, we went to the backup plan of rewriting the interpolator in C to run on our processor. So yeah, that's how our system works. It sounds quite good, I'm sure. Hopefully you had a play with it upstairs, and yeah, we're quite pleased with it. Various extensions are possible. We left space in all our designs. It's wonderful. Imagine the possibilities. Thank you very much.